Hi guys, thank you for joining us today. My name is Luba. I'm event specialist at Intellias, and I hope that this meeting, this webinar, are going to be useful for you, and you will get some great insights and information that you will probably maybe use someday in your life. And while others are joining in, I will just tell you a few words about Intellias. Interesting projects, international clients, global representations, and 8 development centers, and more than 500 open positions. That's what Intellias is about. We create unique software solutions for more than 2 billion people in the world with the help of 2,500 experienced specialists on board. And no matter how fast we grow, we always adhere to people-first approach. And that's why I advise you to check our vacancies page, and who knows, maybe career match will happen. Now, just a couple of technical issues. You can write your questions in a chat, and Anatolii, he will answer them during the presentation at the Q&A session. And please mind, there will be 1 minute delay due to YouTube streaming rules. So that's fine if you want, just answer them straight away. That's it. Let's get started. I would like to introduce our speaker, Anatolii Bat, Principal Java Engineer at Intellias. Anatolii, glad you're here, and the word is yours.
Hello, everyone. So let's start. Just in case you cannot hear me or anything problem with that, please type the message and Luba will let me know. But now I want to start sharing my screen. And let's start. So first of all, a little bit about myself. My name is Anatolii. I work for Intellias almost 5 years, and during this time I work on the projects related to soft that creates navigational maps that are used by the driver, so that are installed to the cars and used for entertainment purposes or like navigation, and also for providing better experience to the driver, like advanced system that help you to help your car to adjust the lighting when you are driving on a very curvy road and so on. And also I work on the system that create maps for self-driving cars. So that's what I do for last 4 or 5 years. But today our topic is about inspections tool. So how to create your own inspection tool. And let's go to the agenda. So first of all, we will start with what is called what is inspection tool in general, why we would need one, right? Then one of the way to implement those tools are Java agents with help with instrumentation. That will be our next topics. And in the end, we have a little demo. I encourage you to check out the project. Luba, please share the link in the chat so you can check out it while I am talking. And in the end, we will try to run this all together. And later you can have this like a template or maybe just some starting point and like create your own inspection tool, which you maybe need on the project or just for fun. And a small notice, during our stream, I will need to make a little pause for like 10-20 seconds just to open door to my wife. Okay, so what is inspection tool and why they are used for? So what they are used for? So first of all, those tools, many of you, I am almost convinced many of you use that is for monitoring, profiling, code transformation, or mocking. Let's take like already available solutions like Mockito, which is a library for testing code for mocking the object while you are writing your unit test. So Mockito is quite interesting library, and in order to achieve all the functionality that it provides, such inspection tooling is used as well. The next tool many of Java programmers are familiar with is Java Visual VM. That tools allows you to connect to the existing Java process and like get some useful information like how many threads you have, what is the CPU usage, what is the memory usage, what are your hotspots, and so on, right? JProfiler, right? That is a profiler for Java, and other solutions. There are many open sourced and commercial solution too. Okay. Now, I think the reasonable question is, but why would we even need such an inspection tool, right? There are many available on the market. As I said, there are free, there are commercial, right? But there might be situation you have very specific need that is not covered by the existing one, right? That might be the one case. The another case that is code is out of your control. Maybe you don't even have an access to source code. You have just compiled artifact, maybe jar, and for some reason you need to adjust it somehow, or maybe you just need to monitor something, like many different use cases. Maybe available solutions that are available on the market, they are too generic. They do not resolve your problem. So that is mostly more about like a first reason when you have a very specific tool. And I think the next reason is very interesting. It's fun. What I mean is that particularly for me, it's like really interesting area when you can create something new that is useful not only for you, but for your colleagues and maybe for the whole community. That's how many such tools started. It's actually really interesting to implement such tooling. And later you will understand why, because like that is a little bit like too early to dive deep, because we didn't cover some topics yet, but just a few words, you work with a bytecode. You modify already compiled program using another code, right? You are writing code that modifies bytecode, and that might be really interesting. Right, and the last reason I would say is that creating such tooling, even for pet projects, you start understand what is going on under the hood, how actually that library works, or maybe how profiler works, or you can just create your very specific compiler so that gives you more knowledge, right? And now what we start with is what we actually need, what we need to create such tooling. There are two steps, I would say, like on high level. The first step is to having an existing code, we need somehow to integrate to that code, somehow like maybe change it or completely remove some part of the code, or just track how many times the method was called, and so on. Many ways how to achieve this. Like the first and very obvious is we can do it manually, but then we don't need a tooling at all. That's it, right? You have access to source code, you modify it, and you get what you wanted. But that is not always the case, that you can modify that code, or maybe you don't want to put such code to your master branch, but you need to monitor something on the production. That's why you cannot use this way. Another way is aspects. Aspect programming is one of the known paradigm. I am sure many of you are familiar at least with Aspect J or aspects from Spring. That's when you say that, okay, this piece of code will be called before, after, or somewhere in between of this piece of code. Like, but you do this in declarative way. You don't put that call of the method directly to your main source code, right? And what we will use today and what we will talk later in more details are Java agents, and instrumentation API. That is our topic, right? That was about the first step. And the second step is after integrating to the code, after having the access to that, we need somehow to change the bytecode that's already compiled, right? And actually, there are many ways as well. Like, at least what I listed here, these are well-known libraries in this topic. So, I mean, the programmers who worked on that instrumentations, inspection tooling, they are most likely familiar, or at least they know these libraries exist. That is Java Assist, Object Web, ISM. ISM is just from like assembler, just part of the name. Nothing special meaning here. No special meaning here. Then CGLib, which stands for Code Generation Library. Then BCEL, which is bytecode engineering library, and ByteBuddy. What we will use later will be ByteBuddy. So we'll get to that deeper later. And now we start with the Java agents. What is a Java agent at all? That is so first of all, that is a part of the Java API. And in order to implement the Java agent, you need to follow special convention. And what is the convention? That is that to be explained. We have slides for that, and also we have a demo. So we'll take a look closer. That this Java agent, so it's code, it can be attached to the Java process. The Java process might be already in progress, or maybe when you start some Java process, you can say, okay, I am attaching this Java agent to this process. Yeah, and what you also need to know that was introduced in Java 5. So most likely you will not manage to use it with earlier version, but I really doubt you need this nowadays. So how does it work? Every Java programmer knows how Java program works. What is the entry point, right? That is a main method in a main thread. When you start Java process, main method starts executing your other statements, and that is quite simple. But after having an agent, what you actually introduce. So first of all, there are two ways how to attach Java agent to the process. The first one, that is not official naming, but like naming that is very often used in different kind of papers, right? If you just Google for Java agent, what is it, how to use it, you might find that static and dynamic agents, that is the terminology used among the programmers. The first is static. What does it mean, static? It means that when you start the main Java program, so your main application, you, at this point of time, you say, okay, please assign this Java agent to it. And in that case, you have a method called pre-main. And in that pre-main method, you have this inspection logic. We'll take a closer look to that on the next slides. As you see, many, like few, one and more pre-main method might be present. So it means you might have attach few Java agents, right? That about static. So what is dynamic? Dynamic is that you actually can attach Java agent to process that is already in progress. That will start in separate threads. So if you take a look the difference, so if you take a look on the picture, you see the difference that pre-main is executed in the same thread that the main method. So it's before the main method. But if you attach dynamically, that will be executed in separate thread, and that might be executed before or at the same time or even after the main method started, right? Because yeah, I think that's it. So we will take a closer look how that it looks on the practice. Here is, we are trying to put it together. So this is a pre-main, so static one. What we do, we just create the class, just a simple Java class. You call it as you want. In this case, that is agent. And you create something similar to main method, but which is called pre-main, right? So that is static void pre-main method that takes two arguments. The first argument is args. The args is what you passed to your agent when you started the process. So just do you remember we talked that for static one, you attach the agent in the point at that point of time when you start the main process. And if you look at the bottom line here, we have a command. How does it look? It looks like Java minus Java agent colon my agent.jar. This is artifact you should package of this code. So there is no other way. You should prepare the jar artifact. And then we have equals and my agent arguments. So these my agent arguments are exactly that parameters that you will be able to access via this args parameter. And the next one is instrumentation. That is part of the instrumentation API provided in Java. That is that for that we have a separate slide, and I will explain it like in more details. What does it mean? Okay, having this code, as I said, you need to prepare my agent.jar, or you can call it as you want. Obviously, there are one important point here. You need the manifest file where you show what is your pre-main class. In this case, we have pre-main class is equal to com.intellias.tooling.agent, exactly this class. And two other properties, two other parameters, which is can redefine classes and can transform classes. So what these two means? The first mean that whether your agent can change the bytecode or not, right? And in case we want for our static agent with the pre-main method to be able to change our bytecode, and usually we want, we say that, yeah, that's true. And other one is retransform classes. So retransform classes means after class was already loaded by the class loader, maybe even executed few times, right? But at some point, someone connected to the process using dynamic agent and want to retransform the class. That is the way we say retransform classes true. That means that this agent will be able to retransform classes. But as you understand, in current case, that should usually not happen because pre-main is executed before main method, right? And that means that we already injected before before class loader loads all other classes needed to for our application, right? So another way is dynamic one. If you look at the first part of this, there is a little change in the method. It's not a pre-main, but agent main, right? The same arguments, so we skip explanation here. The difference is agent main, and the difference is how we attach to the process. And actually, in this case, we need a separate Java virtual machine, separate process that starts and executed this code. So this one is a little bit tricky. It's included in our demo session today, and I will explain why it's a little bit tricky and where you should pay attention to. But after you know these pitfalls, I think you are fine to implement your own inspection tool. So this is just a way how to attach to already running Java process. Okay, let's go on. Now we are at instrumentation. If you remember instrumentation, I'm going a few slides back. Instrumentation was our second part of the first step, right? So we need Java agent plus instrumentation. And also we solve this instrumentation interface here. And now we are explaining what does it mean. So that instrumentation interface is part of instrumentation API. It's included in runtime jar. So you see this screenshot. I was just took this screenshot in my IntelliJ IDEA. By expanding the tree, we see that Java lang instrument package. We have few exceptions here and two interfaces. So actually only two interfaces we will work with, like entry point, right? There are more in order to transform your bytecode, but to integrate only two interfaces, quite simple. That is class file transformer and instrumentation. So instrumentation, it has a next methods. As you remember, instrumentation was a parameter in the pre-main or agent main method. So it's already created for you. You don't care about instantiating the instance of that instrumentation interface or whatever. You already have it. You just can call existing method there. And like there are other methods. These are main method we might use. It's add transformer, which means for our current instrumentation, we want to add class file transformers that will somehow change our bytecode. But how? That is the detail of implementation. And this is the point where those libraries for bytecode manipulation are integrated. You can even do it manually, right? We will take a closer look to the method, which is method transform. And I'll explain it, right? So class file transformer, this is what you implement. Next slide, this is the method you implement, but we will get to this and explain every argument. So what next? You also can get classes that are loaded, and you can retransform classes that are already loaded, right? Maybe not all of them, because we have vararg here. So you just put like many, maybe one, maybe two, maybe all classes. That's up to you. So now back to class file transformer. Class file transformer, the method you implement is method transform. We start with two most important points here is what is main input, what is main output, right? So main input is class file buffer. Actually, this class file buffer, this is just a bytecode. So array of bytes, it's bytecode that Java compiler created from your source files. What you have as an output is also array of bytes. So you actually can modify it manually, but that is not very, I mean, not very easy, first of all, and it's not fun at all, right? Because that is bytecode, you might miss some stuff, and I don't think, I cannot even imagine the use case where to apply it. So other arguments here is loader. So you have access to class loader. Usually it's not needed, but in some more complex cases might be needed. Then a class name. The class name is actually the class that you are transforming now. Let's say you have class person. So what you get here is a person. Then you have a class being redefined, and actually there are two cases for this field. First of all, if this is pre-main method, most likely the class is not loaded yet. It means you obviously have a class name, but you do not have a class like a class in Java, right? In this case, this parameter will be null. But when you are transforming already loaded class, then yeah, you will be provided with this, and that might be somehow useful. So protection domain is for checking some rights. We'll not touch it today, and class file buffer, that was already discussed. Okay. I think that should be clear. Luba, any questions here at this time?
No, we don't have any for now. I will send it to the chat if I will get a few new questions.
Okay, great. So we continue. Now, the second step after we integrated to process is manipulating the bytecode. And as we discussed previously, there are few possible options, right? What we look at today is a byte body. Byte body is an open source library that is actually built on top of Object Web ISM library. I have a slide with byte body, separate slide for byte body. And what I just wanted to point here is that this was developed by Raphael Winterhalter. So there are many tutorials. There is a blog. You can check documentation as well. It's well documented. So recommended to use, but again, you are free to try any of these. Me personally, I have experience with Object Web ISM. Also have a little experience with byte body. So far, I like byte body more than this one. It has a nice advice API, right? And what is advice API? That is something similar to aspects, right? But in terms of modifying bytecode. obviously open source, so it's free to use, and as I said, well documented. Okay, let's take a look at advices and how does it look. So what we have on this slide is just a simple Java class called process method advice. Well, actually the name is not important here. And two method on start and on finish. The names are actually not important too. But what is important, these annotations. These annotations allows ByteBuddy to understand that you want to inject this logic to your existing code. But on the beginning of the method, so that should be the first statement. And here we have on finish the same, but in the end of your method. There are many other annotations you can apply to this, like maybe you want to use fields that are present in this method, or maybe you want to access internal local variables that are on your current stack of variables, right? You might need to access that, or maybe you can want to access the class itself where you want to modify the code, right? There are ways to do that, so you can actually do incredible stuff here. At this point, it might be a little bit confusing because you do not see a whole pictures yet, how to integrate this advice to actually instrumentation API. That will be explained in the next slides, and that will be showed during our demo. So no worries here. Here is how we integrate it, right? On the agent main example, but exactly the same will be on pre-main method. So this is API provided by ByteBuddy. What we do, we create agent builder. So there is even agent builder API, which is way more convenient than if you create it on your own. What is important here is we call method type and say that we want to transform this class name. So here we provide a class name. And then we actually say, okay, please transform those class, that type using this builder, which is given to you, right? So this is Lambda here, but you can implement a class or whatever, does not matter here. You just need to provide transformer, right? So for builder, we say, okay, please visit on this type, this method, which is named my method, and apply to it this advice. And advice is described here. So why is this API so nice? First of all, when you try to modify bytecode, you do it just by writing another Java code, right? You have type safety. You have type safety, and ByteBuddy guarantees you if your code compile here, it should also compile like in the runtime. I think you might create something something that will introduce the failure, but very unlikely. And after we created this agent, what we do, we just install it on our instrumentation. So if we take a closer look, we see that instrumentation is used only one on the last one on the last line. We say, okay, this agent builder installed on instrumentation. That's it. And I would say that is main theoretical part, maybe most boring part for many people, but now we start with a demo. This slide I'll use a little bit later while we take a look on our inspection and describe what is this and why it is needed. Okay, I hope many of you was able to check out the repo. Now I am switching to inspection tool. So just in order to have better visibility, I enter presentation mode here in IntelliJ IDEA. And also I have a plugin installed, which is called presentation helper or something like that. So it means if I use some hotkeys, you are able to see which hotkeys am I using. It looks like something happened and maybe it's broken in the latest IntelliJ IDEA version, but the first time I press it worked. Okay, so for this purpose, for the purpose of demo, we have one project with a main POM file, just in order to have it like in one place and switch between them quickly. So it's just for convenience. So we have three modules. The first one is actually our application. That is business logic. That is your main application. You want to inspect, monitor, modify, whatever, right? And we will start with it as it's most simple one. So if we go here, what we have up main, which is actually nothing else like a main method. Then we create some logic, right? And call the method named main processing logic. I go inside, and what is the logic? Quite simple, right? We go line by line. We create a variable called I, and then until method process, so while method process returns true, we just increment this variable and repeat the same. Quite simple on this level. And what is method process? Method process print the line that says, okay, check something, and print the value of I, which was passed inside. Then it sleeps for 2 seconds and always return true. So quite simple quite simple application. What it means, it will be always printing the it will be always printing the check with incrementing the I variable. So what I do now, I just build the project. So I build the project here. You can repeat the same. The package is enough because what we have POM file, and there is a plugin for creating the jar package. So just creating the jar file, and I will start this application right now. It will be in progress. So you can do actually the same. I'll do that in the console. So what I do here, I open this in Explorer, right? Okay, it is here. And I started via PowerShell because I have Windows subsystem Linux, but that's broken now. So I just start the application, right? And that's in progress. You see, right? Check 0, 1, 2, and I leave it as it is. We continue exploring the other modules while our application is in progress. I don't need Maven anymore because all projects are built now. Then we have inspection agent and inspection application. The reason we have two, so first, you remember, right? We need to create an agent anyway. That should be separate jar. This will be our inspection agent. this will be the module where we keep our advices, where we keep logic of bytecode manipulation. Is it byte body or manual stuff, or maybe like ISM library, whatever. And now what I want to do, I want to attach to already to the Java process that is already in progress. That's why the strategy I select here is dynamic agent. And if you remember, there was a slide where we had something like virtual machine attached to some process, and that will be put into inspection application. But before that, we dive deeper into our agent. So first of all, as I said, I need stuff that is called pre-main class and agent class. Also, what I need is can redefine classes and can retransform classes. Okay, this will be our part. This will be part of our manifest. So you have this in a project and you can reuse it for your stuff if needed. Okay, let's take a look at the agent itself. As you see, agent is this class, so I can go directly from here. So one thing I didn't told you when explain dynamic and static stuff is that in reality, you can implement pre-main method and agent main method in the same class and reuse logic. So it means you can have these like two separate entry points to the agent, but those agents will use the same transformation logic. That is also possible, completely fine. So that's what we have in my case, but the only difference is that I'm just ignoring what is being done here. So I just return null. And few words about returning null here. So you remember that we have transformer. Our transformer contains a method transform that should return array of bytes. And if you look at my implementation here, I am returning null instead of the array, some real instance array. So what I could do here, actually I can just say class file buffer. That will work. The reason why I am returning null here, it's a marker for Java virtual machine that, okay, if the null was returned, it means nothing was modified. Because in case I return the same class file buffer, what will Java virtual machine do is just try to actually retransform everything. There is no additional check between input and output that says, okay, maybe this bytecode was not modified. There is no such check. And Java virtual machine thinks that that class was modified. And that is a little bit extra. So in order to avoid that, what you can do, you can return null here, right? Okay, that was pre-main, but what we want to achieve is to attach agent to process that is in progress. And what I do here is like very simple stuff. So first of all, I get the arguments. I parse those arguments. There is like, I would say, very poor interface contract for my demo. So never do that. Like create some nice interface contracts for your agents. But what I have here, actually, I expect that to my agent, the client will pass class colon method, right? Like here. Or even that, I think that is obsolete, right? That is not needed. Okay, great. Just found misdocumentation here. That is not needed. I just have like two components, x colon y, where x is the class and y is the method name, and I return like method identifier, which is class name and method name. So just a simple, very simple parser of the arguments. And what I do here, I say, okay, I create an agent builder. This is for some performance reasons. So this is recommended by the Winterhalten to use this method in order to get better performance, because that disables some parent method transformation. So we keep it like this. Also, we say that we want to retransform our class. Then we say a type, and type is one that we get from the input parameter. We say named, and this will be just a string. So of course, if you do not have a parameters, you have very specific tooling. You don't want to parameterize it. You just put a simple string here like com and something like logic, right? But in our case, we have method identifier get class name. Then we add a transformer. A transformer, we'll take a look at it soon. After we added the transformer to our agent, we installed that agent to our instrumentation API. And that's it. Actually, if you go inside the install on method, if you find the implementation and go further and further, at some point, you find something like this, add transformer, right? So there are many other like cases. You see ifs are added here and so on, but in the end, there is call to the add transformer. So you can do this on your own manually. And just let me go back to our presentation. You remember this method, add transformer. This is part of instrumentation API. Here it is. That is done for you, actually. So you don't care in this case. So this is creating and configuring the agent. Now we are getting closer to the transformer. So if we take a look on the transformer, what it actually does, just implementing the interface transformer. You can this stuff should be, if I'm not wrong, even functional interface. Yep, that is a functional interface. So you can easily implement the Lambda, but I decided to move this to separate class just for better readability, and it's easier to explain what is going on here, right? So we have method transform that already takes the builder, type description, class loader, some Java module, might be used in Java of version 9 and later. So, and this is what we described in our presentation. We take a builder and try to visit our class, find there a method that are named this way. So this is from our configuration. And we apply advice to it. And now we go to advice. So this is our transformation logic. What we do here, we introduce two methods on start and finish. We mark them with a on method enter and on method exit. You know that some method might have return value. Some might not have return value. In our case, for our demo, I selected a method that return a Boolean value, just because that is like more interesting to show you that it's even possible to change the return value. So even with this simple API, because using the advice, what you actually can do, you can integrate in the beginning and in the end of your method, but you cannot integrate in between or get something out of the method. So at least those versions that I was working with. But again, that is about byte body advice API. There is another part of byte body API which allows you to do that, which allows you to modify the method in between your statements, right? So that's possible. So back to this. Back to this. In our case, I want to modify a method that returns Boolean value. And in order to do that, I need to use this strange thing, because what would you expect it maybe from API that, okay, why we do not say instead of void, why do we not say Boolean here and then just return false? For some reason, I don't know the reason, but for some reason it's not implemented. Maybe it's not so simple as it looks. So what you do, you introduce the Boolean, input parameter. You mark that Boolean input parameter as a return, right? You say that it's not read only, so you can modify it, and inside you assign the new value for that, and that will be actually the value you return. I actually just now I have a new idea why it might not be implemented via return statement here, because in reality you can have a method that have few exit points, so few return points in your method, and in that case you still integrate to the very end of your method. So if you return somewhere in between, you actually cannot change that. So I think that is the reason why it's implemented in this way, but does not matter now. I think just interesting idea. Okay, I hope this is more or less clear. So once again, summarizing: on start method, introduce time to finish, and and end method, introduce okay, that's enough, stop. So what I want to get after modifying my bytecode, I will do the next stuff, right? I am taking these two, right? I'm taking these two, and now I open the logic. I open the logic, and I put it like here and here. So I put it here, and this is false. So this should be the change. What I introduced to my code, I added the time to finish, but you still have one try. Then middle of my method is executed. Then end of my method is executed, and I return the another value, right? That's it. So roll back in this to the initial state. And now let's go back. So actually that's it. that is all about our agent, like a very few classes, could be even less classes, but I try to put them at least somehow in different files, so it's simpler to understand, right? But I could do this even in even two classes would be enough. One for introducing the advice, and this agent could do everything here. That's it. Okay, and the last part. The last part is inspection application. After understanding this one, we actually can see the whole picture. This is a one big not refactored class, but I'll explain it very, very quickly. There is no like complex logic. So first of all, we get the arguments. We check there is exactly one input argument. We get that argument and check that there is a file. So we expect some file. And then that file should be the path to the agent. So our agent, which we created here. So you remember we ran package command and when package command some time ago. As a result, we get agent in our target folder, which is named inspection agent snapshot.jar, right? So what we actually expect here to this another Java application is the path to this agent. Okay, now having this, we try to attach agent to our virtual machine. And what is our virtual machine here is we get local monitored virtual machines. That is separate method. If you are interested in how it's implemented, you can dive deeper later. I don't want to go into details now. There is used one part of API. I'll tell you which one and how to attach that or how to add that to dependencies because it's not added by default. So we get the list. If that list is not empty, what I do here, I select virtual machine to attach. So I just print all the virtual machines that are in progress now. I mark them with the index. I ask user to select which virtual machine I want to attach now. And after user selected, I get the process ID of that virtual machine. And here I do the magic, right? That part. I attach to virtual machine this part, this part, and this part. So these three main lines. I attach to virtual machine, I load agent to it, and after agent was like finished, after the main part of, after the method was execute of the agent, I just deattach from the virtual machine. So additionally, I ask here for the class to transform and method to transform, but that is just in order to like make this program a little bit like more complex. So to show you how to pass the arguments, to show you that you can get the arguments from inspection application. Later, you can develop the user-friendly UI interface, user-friendly UI with buttons like and so on, something similar to Visual VM, but for your needs. And that's it. So before starting this, many of you might not be able to start this inspection application, and I'll show you the reason now. If you go to the pom.xml in the inspection application here, we have one dependency, and if you take a look, you see there is a scope system. So what does it mean? Actually, you do not have access to virtual machine API, right? That virtual machine API is placed in the tools.jar. So there are many other classes, but that is not part of the Java runtime library, right? Which is rt.jar. That means you should add it to class path separately. And what I do here, actually, I just add the path to my tools.jar. In my case, I have a environment variable which is called Java home, that point to my Java home, where is folder lib, where inside I have tools jar. So in order this works for you, you need to double check that Java home is present in your environment. If not, you can add Java home environment variable, or you can just put the whole path here. That will also work, right? I put Java home in order, like, in hope that most of you have this environment variable. Okay, after that said, now we should be able to start the application. And I'll start inspection application in IntelliJ IDEA. The reason why I'm doing this is that because of exactly this dependency. In order to gather the jar, I additionally need to copy this stuff to some library folder, gather it to package it to jar file, and show in the manifest that please add this tools.jar to my class path in my library, so it's like working. It will be it will be like available, right? So, but in case I start this in the IntelliJ IDEA now, it will find this dependency via Maven. So this is just a question how to package this stuff. Okay, and I already have prepared the configuration, and I'll show you what. So I have inspection application as a main class. That's quite easy. If you just start inspection application, there is a main method. IntelliJ IDEA will create the configuration for you. And next, what I pass as a parameter is the full path to the Java agent. In your case, this will be something different, right? Because in my case, this inspection tool is by this path. In your case, that might be different. So just ensure that you pass this argument to your inspection application. What you also can do if you like are struggling with passing the parameter now, the easy way, the hacky way, let's call it, you can just change the stuff here, right? Remove this and pass the agent directly here. So whatever you want. So now I want to run this configuration, inspection application main. So that started. Not started yet, that's starting in progress. Compilation. Okay. What I have now is select virtual machine to attach. And what we see, application jar with dependencies, this is one we are interested in. And in order to have some visibility how it works, I will do this way. Okay, and I need to exit presentation mode so I can put window side by side like this one. Okay. And we see that this is still running, like already 700, quite a lot. Select virtual machine to attach. So I want to attach to the virtual machine under the index 1. And that virtual machine has process ID 19136. Okay, enter. What I have a message. Okay, you attached successfully to this process, but now please tell me the class you want to transform. So the class I want to transform is actually our logic placed here. So exactly this class we have here. So what I say, okay, com Intellias application logic, right? Okay, and please tell me the method you want to transform. The method is process. So this method, you even see this method is private, right? Method process. And now I press enter. Yep, we have a result. This was de-attached, and exactly at that moment, what we have a new logic. Time to finish, but you still have one try because that was the first line in our method, right? So we still have a one try to execute the old whole body of the method. It's executing, like check 809, and there is a line at the end. Okay, that's enough, stop. And after that, we return false. So this is how we change the bytecode in runtime while your application is running. Your classes were already loaded by the class loader. Still, you can have this powerful tool to access the runtime code, to modify it, or maybe just track, right? Some time ago, I tried to develop a very simple profiling tool, like very specific for my needs, and it was working, like very useful stuff in that situation I had. And it was like even faster and simpler to do than try to attach already existing solution. Like, I don't want to go into details. Like there was a reason for that. In your case, you might not have a reason to implement your inspection tool, but at least now you are aware how to do that, and you can do that at least for fun, and at least to understand what is going on under the hood, right? So as I planned, we actually finished faster, like 20 minutes faster. That was a demo, and let's still we have a time. So this one was explained, right? What you need to do in order to add the tool jars to your class path. The one way via Maven dependency, that's what I did, but you also can use minus class path option when you start your application. And that was a demo. Demo link was shared. So few words about what else you need to pay attention to as well. So it's if you are really developing like maybe some source inspection tool, but on your or inspection tool on your project, and want to use it for like day-in-day activities and your colleagues too, you need to test that stuff. That's important, right? Because especially with agent main, where you attach dynamically to the process. And the reason is that that is a separate thread, if you remember. So maybe some interesting situation can arise. Also, you need to understand how class loading works, because in one application you might have few class loaders, and yeah, that is also important. There might be some pitfalls if you start working with these and get more and more knowledge, experience. At some point of time you can or just your application is getting bigger and more complex. At some point of time you can understand that, yeah, there are like some issues with class loading, or you just can face them. And also, if you are developing such tools, you should pay attention to different Java versions, because your inspection tool in the end should work correctly with different Java versions. But lately, Java has evolved, right, quite a lot, and that might have some impact. Thankfully to community, those libraries I shared with you, they are evolving too. So let's say there is new Java version, right? There is like few months, maybe a few weeks, you have a new version of the library that is able to transform your bytecode, right? That's it. Okay, that's it from my side. I thank you everyone who joined today. I was glad to share my experience, and hope this can be somehow useful to you, for you in the future.
Yeah, thank you so much for a cool presentation, Anatolii. I just can see here people are grateful and just saying thank you for demo, for presentation, for a cool speech. Just a short reminder that I will share the presentation and the recording of our speech tomorrow by email. And if you still have some questions, you can write them now, but I think it was just, you know, enough info for everyone to get the point of Java inspection tool. Yeah, I guess we don't have any more, but anyway, if you would still have questions, you can leave them in the chat and we will contact with Anatolii and probably he will answer. So thank you once more, and I wish you guys a great day and stay safe.